So, hello and good morning, everyone, and welcome to this session on Advanced Driver Assistance System or ADAS in our track on onboard electronics. My name is Pranjal Srivastava, and I am the field application engineer responsible for South Germany, Austria, and Switzerland. I'm based in Munich and would be the host for this session. Some housekeeping rules before we dive deep into ADAS. The expected duration of this presentation is about 25 minutes, followed by a 5 minutes Q&A round. In an effort to have the most optimal environment for everyone involved, attendees will be muted during the presentation. You can address your questions at any time during the presentation with the Q&A function of the Zoom session. Please, if possible, note also the slide number to which your question is related. We will answer your questions during the Q&A session. If we run out of time, you can also submit questions at go.chemet.com/tid minus contact. We will follow up with your question directly after the event is over. Also, this presentation will be made available for on-demand viewing after the event is over. Lastly, once Design a Day is over, you will receive via email a short survey. Your feedback helps us to improve our future events. With this information, I hand it over to Alexander Nebel. Hi, Alex. Thank you for your time today. Please tell us a little about yourself before you begin your presentation.
Yes, hello Pranjal, and thank you for your short introduction. My presentation today will cover the advanced driver assistance systems. And short information about myself. I'm in Chemet since 2017, but I've been before also research and development engineer, hardware engineer, and software engineer. I was in a company selling passive components as sales engineer. And more than 10 years, I was the FAE, the field application engineer for passive components. And today at Chemet, I'm responsible for automotive customers in Europe. So this is just a short background. And now I want to show you the agenda for the next, let's say, 25 to 30 minutes. So I will give you some slides, a view on the background of ADAS applications. Then I show you the application itself. I took out two examples, a camera module and a radar module, to show where we can place Chemet or Yageo products. And finally, I will show you especially the Chemet ACQ 200 qualified product overview. And then my last slide is a short summary to give you an overview about which technology fits the best in your application. But first start with the background of ADAS systems. So in general, assistance systems have a long history already. So when we look back in the history, we can see that cruise control was already adapted in the year 1945. And also some other technologies like the first autonomous driving car is already done 43 years ago, or 44 years, which was in 1977. Also in 1994, we had already the first car which drove 1,000 kilometers fully autonomous. So this was the Eureka Prometheus project. And also there was one project just 1 year later, which was No Hands Cross America. Well, the name says it all. And in addition to that, we have the adaptive cruise control from Bosch in the year 2000, or the blind spot detection, or the active brake assist. All these technologies are a long way in the history of assistance systems. When we think about totally autonomous driving, we don't have just autonomous driving, yes or no. We have different levels, level 1 to level 5. So level 1, we would describe assisted driving. So the driver still controls the car and views always the traffic, and he has the full responsible. But the system can assist the driver, which can be ADAS, for example. Level 2, which is partly autonomous driving, and this is roughly the standard where we are today with our cars. This means the driver controls the cars and he always views the traffic, but he can give some responsibility to the assistance driving, for example, for the track keeping or braking or accelerating. But still the full responsibility is by the driver. And then we can go to level 3, highly autonomous driving, where he can partly turn away from the steering of the car and lay back, but he still is responsible if he ignores the signals. Level 4 would mean fully autonomous driving. I can lay back, I'm sitting still in front of my steering wheel, but the car takes over the control for, let's say, a longer distance. And finally, level 5 autonomous driving would mean that I'm only a passenger. I have no steering wheel. I only decide where I want to go, and the car brings me there. It's like if I'm sitting in a bus or in a taxi. So now, what is the application? What does ADAS mean? Well, I have already said it's the Advanced Driver Assistance System. Okay, for sure. And it's the first step to autonomous driving. So we need an ADAS to get to the point, to the level 5, to be the passenger in the car and have no longer the control. And we have different ADAS systems. And for example, I already mentioned some, is the adaptive cruise control. We have this blind spot detection. We have the rear cross traffic alert. We have emergency brake assist, lane departure warning. There are many, many more of these. But all of these have some things in common, because the requirements for ADAS is always to have sensors. Either if it's a camera, radar, or LiDAR, we need sensors who always view the traffic or anything happening around me. Also, we need a control, for sure, that's clear. And inside the car, we need a high-speed data network with high bandwidth, because we want to have the data immediately coming from the sensors to my control unit. The next step, which is very important, is that we have a secure system which works under harsh conditions. Just remember, your car is driving in winter, in summer, it's raining, there are many effects from outside which can affect my car and the functionality. And we want to be secure always, and not only when the weather is ideal. And the last point is we want to minimize the failure rate of my system. Okay, let's have a look at the current status. And I mentioned level 2 is where we are currently in the year 2021. Level 2 cars with, let's say, adaptive cruise control, lane assist, and park assistance need roughly 17 sensors to give the full function to your car. If you look now at level 5 cars, then you can see you need more than 50 sensors to fully take control of the car, which is 3 times higher than the level 2 cars. And this means for the future, there needs to be a lot of more sensors like cameras, radar, and so on to fulfill this level 5 situation. So there will be more sensors, there will be more parts needed in the car, but we don't want to grow up the car, we don't want to have bigger PCBs. So the main requirement for passive components is small size components. So, and here on this slide, you see in general CAMIT components, which are available in small size and are qualified for automotive applications. So for sure, you will always find MLCCs. This is a standard product. But also, if you want to go to higher capacitance ranges, you need maybe a polymer tantalum capacitor. Also, when we stay in the capacitor world, aluminium electrolytic, or maybe the newest technology, aluminium polymer or aluminium electrolytic capacitors. I will show an overview of all capacitors at the end of my presentations, and then you can also see which are the advantages and disadvantages maybe. But we need also power inductors. We don't only need capacitors, we need inductors. And we have here the latest and newest series for very high temperatures, which is called our MPXV series. But still we have some series from the past, which are not the latest versions, but which are still a good solution for some applications. And then we have flex suppressor sheets. Flex suppressor sheets is just a filter which you can put behind a display to not have any effect on your car, on your display. Now let's take one example. And I took here one example from Texas Instruments. And here you can see a camera module. And exactly this here is the camera module. And the first view, we can see it's a small component, or it's a small PCB. And this means we need small SMD components on the board. We cannot think about big components because we need space in the car. And when we want to increase the number of sensors by 3, then you can imagine we cannot increase the size of the components. Maybe we have to think about minimizing. So this one is a scalable automotive 2 megapixel camera module without processing. So this module is complete. It can replace a camera mirror system, a mirror, and this could be a camera mirror system for your car, like we can see maybe already in the new Audi e-tron models. This is also possible to use it for a surround view system. So this is a general camera and maybe also for rear camera. Okay, the block diagram, when I look into the block diagram, my first thought was, okay, I can see MLCCs I need, or capacitors, I need inductors. This is perfectly fitting for CAMET components. And now the next step would be, let's have a look in the BOM. And then I took the data sheet from Texas Instruments, and I can see that is nice. We have only for the voltage supply, I can find 3 buck converters and 1 LDO regulator. I have input voltage somewhere between 5 to 18.3 volt, and I need different output voltages, 1.2, 1.8, 2.8, and 3.3. Well, it's very clear I need inductors and I need also capacitors. In the data sheet, some components are referenced, but also when I try to find components, I can see many different solutions and we can support them from CAMET. And as I mentioned before, for the inductor of your DC-DC converter, you can use our latest MPXV series. So in the buck 1, buck 2, and buck 3, the inductor can always be found from the MPXV series. No matter if you need 1 microhenry, 1.5 microhenry, or much higher inductance values. Also, capacitors we can cover fully with the MLCC solution. So this one is a very easy example. But let's go now one step ahead and let's have a look at a radar module, for example. Well, and here I took a Texas Instrument example. You can find this also on the internet, so it's nothing hidden. And this is a radar module to detect objects like cars and trucks up to 80 meters away, with a range solution of 35 centimeters, or if you want to have a higher resolution of 4.3 centimeters, you can detect cars which are 20 meters away. So the usual applications for this one is also a lane change assist, autonomous parking, cross traffic alert, and blind spot detection. And now, again, like in the example before with the camera module, let's go one step deeper. So this is my block diagram. And again, I want to have the power supply. Here I can see a list. Oh, this is a long BOM. And we can see many, many capacitors which are covered by the MLCC products. MLCC range is good in the range of 1 digit, maximum 2 digit microfarad range. So I can find 1 microfarad. I can also find 100 microfarad. But there's one product I took out, and this is marked by yellow color here. This is a T598 series, which is a polymer tantalum capacitor. Exactly this capacitor here is perfect to use in this application. And I will show you in the next few slides where are the advantages and disadvantages. But keep in mind, 25 items can be covered easily by CAMET product just for this application, just for one application. And there's no product where we have no solution. Now I want to show you the most pros and cons of each component. So ceramic capacitor is what we found in my examples most of the time, because the biggest advantage is they are small size. They can be placed in any conditions, so this is perfect. And we can find voltages up to 250 VDC, which is a good thing, because in normal ADAS or let's say electronic devices in automotive, we don't need more than 250 volt. Please keep in mind, we do offer at CAMET higher voltage ranges, but in this example, as we are only talking about electronics, I just took my focus on the 250 volt DC, but we do have higher voltage ranges. So the most used common dielectric is X7R, because we can go up to 125. We do offer X8R, X8G, and X8L if you need higher temperatures up to 150 degrees. For sure, we do offer flexible termination. If you need 5mm flex performance, which is always a requirement in the automotive world, we offer this, and this has a special part number, and you can easily distinguish if this is a component with flex termination or without flex termination. And for sure, something like PPAP and Volkswagen 8088 norm approved items are always available. Now, the next step I've shown is our tantalum polymer capacitor series. So our T598, T597, and T599 series. All of these are available as well with full ACQ200 certification. The voltage range is some kind of limited. So the highest possible voltage range for the moment is somehow 50 volt DC. Please keep that in mind. We cannot offer 250 volt DC like in the MLCC range. But the good thing is, if you are in the electronic like ADAS, you are not highly interested in having a high voltage range. We have a special range also like the X8L, X8R series in the MLCCs. We have a special series, the T599 series, which offers temperatures of 150 degrees. And here we are first to market. Now, if you think about miniaturization, we have 4 different case sizes which might fit into your application. Those 2 on the left side, you might have seen many times before, also with the classic yellow tantalum manganese O2 capacitors. We still offer them also in black when it's polymer. But for sure, if you want to have smaller case sizes, we can offer case sizes which are similar to an 08, 05 capacitor or whatever component you might compare it with. So this size is really small, it's our P case and can fit on any 08, 05 landing spot on your PCB. Well, now we have a next technology, and this is a quite new aluminium polymer capacitors. For sure, here we are not really the smallest size, but we can offer a very high capacitance range. So don't think you get this in a few millimeters height, but the main advantage of this component is you get it up to 2,700 microfarad. This is not possible with polymer or MLCC. So this is the main advantage of the aluminium polymer capacitors. We have different series. Also, we have a series which has a long lifetime, because everyone, when he hears electrolytic capacitors, might think, oh my God, I have an issue with lifetime. And the lifetime in this product is not the biggest limitation. If you have a higher voltage range, or if you can cool down the component or the PCB, then the lifetime can also be much longer. We offer high voltage series up to 100 volt, which should cover all the ADAS applications with a lower voltage range. And also here we can offer higher temperature series for the moment up to 125 degrees centigrade. Finally, at the end of my presentation, I will show you a summary of all of these technologies to see the main points of each technology. But before I show you that, I want to show you also our inductors. Inductors in any DC-DC converter of the power supply are the most important components. And here we offer our MPXV series. And it's very simple. Whenever you see a V in the part number of CAMET, it's an automotive component. So the MPX series is the standard and industrial component, and the MPXV series is for automotive application. This one is a metal composite shielded inductor. And this technology is also available from any other competitor. We have a very wide inductance range from 100 nanohenry to 100 microhenry. And also we can cover currents up to 100 amps. We do offer different case sizes, and you can see here a list dependent on the inductance value on this bar and rated current, and the size is given here by different colors. So if you want to find the size of, let's take the purple one, which is 6 by 6 millimeters and has 5 millimeters. Then you can just take the purple line here. And if you want to try to find 10 microhenry inductor, the highest available current might be something at 4 amps. So it's very easy to read this part, but it's much more easier to read the data sheet if you need more information. Sometimes the current range is not high enough, and then we have the special series MPLCV series. This one is a metal composite shielded inductor, as well as the technology we have seen in the MPX4, but this one uses flat wire. And this might be interesting if you want to have higher currents or if you want to have special case sizes. Let's say the downgrade of this component in comparison to what we have seen before is that the MPXV fits to common used soldering pads. So here we are now single source. You can find this design, this pad geometry, also the size of the component, also at the competitors. So if you want to have a single source, or let's say if you want to have a second source, you can take our component and take the others as second source because you want to use the CAMET component, right? And now finally, I want to give you the summary and the highly expected slide, which shows the main disadvantages and advantage of each technology. So first of all, let's take the points out of my presentation. The ADAS application requires products that are small size because we do expect more and more sensors in my car. So I do expect more and more PCB space in my car, but I don't want to have a bigger car. So I need to do minimization. So small size is always the most important point. At the same time, yes, low cost. Nobody wants to pay high amount of money just for the electronics. But at the same time, we need high reliability. This is what I mentioned. We need to be resistant against any environmental impact, like temperature or water or whatever can happen inside of the electronic of a car. Also, SMD is preferred here. Yes, we at CAMET do offer big components in THT, but for this application, we are mainly looking into SMD small size components. And for sure, this is something I don't want to mention. ACQ 200 certified is a standard, and we do offer this for all components. And our CAMET portfolio products offer from each technology with a full automotive qualification with these requirements we can see above. This is something I want to highlight here. And now let's come to the final slide where I want to highlight each technology. Now we look only on the capacitors for sure. And this is a situation where you sometimes are faced with and asking, well, should I replace a ceramic capacitor with a polymer? Should I think about using aluminium electrolytic capacitor? Does it make sense? Yes or no? Where's the advantage and disadvantage? And maybe you might think, I take ceramic because it works, because tantalum I don't like, and aluminium electrolytic, they have a limited lifetime. But finally, I will show you now the differences. So by looking at the capacitor range, you can see, okay, aluminium electrolytic or aluminium polymer is something which covers a very high capacitance range. So this is a pro. The voltage range of ceramic goes up to 3 kV. This is a big pro. So here we are at a nice range. Okay, the size range of ceramic, I just did it in millimeters and to have a comparison. And what we can see here, okay, for sure the ceramic is the smallest item I can get. If I look at the lifetime, in this case, my tantalum polymer capacitors have the perfect lifetime, the longest lifetime, have no derating, so I can use them for a long time, which is at the same time some kind of limited for the electrolytic capacitors. Now comes the best thing, price per piece. Well, I don't like to look at the price per piece because price per piece might think that the ceramic is always the cheapest version and the tantalum polymer is always high. But you never want to place one by one. You don't want to take one ceramic capacitor out of your design and replace it by one tantalum capacitor, because the capacitance range or the voltage range is totally different. So maybe you can replace a total capacitor bank of MLCC by using just one tantalum capacitor. And this is where I want to look at the price per microfarad. Well, what does price per microfarad mean? Let's have a look at the next slide, because here is the information you need. Price per microfarad is, I want to have 100 microfarad at 100 volt. If I take 10 microfarad at 50 volt, the picture might look totally different. But if I want to cover 100 microfarad at 100 volt, the ceramic capacitor is the most expensive solution, so it's not longer good. And if I want to have a look at the price per volume, well, that's funny. The electrolytic capacitor, which is in its size range very bad because it goes up to very high diameters, But if I look at the price per volume, and again, I took here the example 10 microfarad at this sports space, which is defined. This is just one example. I'm not covering all. But in this condition, this is the lowest price per volume I get. So it's a cheap version, actually. And this advantage just comes from the highest capacitance range. So I marked everything green, which I think it's very good. I marked everything red, which I think, I don't like this one. And yellow, it's okay, it's medium. And what you can see is each technology has some green points and some yellow points and some red points. There is no technology which is perfect in all ranges. And this is why MLCC is not always the best solution. If you are looking for high capacitance range, then the ceramic solution is no longer the best, because A, we only have 22 microfarad. To cover 100 microfarad, you need to have more items in parallel, in this case 5 items. And I'm quite sure 5 ceramic capacitors in parallel are more expensive than one tantalum capacitor with 100 volt. And therefore, the price per microfarad in the higher capacitance range is much more expensive. And here you can see, well, let's have a look at your application to find exactly the best solution. Unfortunately, I cannot tell you what is the best solution, but the good thing is you can have finally this presentation as PDF, and then you can read it, and then you can find out which components fit the best. And if this is still not enough, please ask your sales engineer from Chemet or your field application engineer. He can help you to find the best solution out of our many components which can be used for ACQ200. And with this information, I'm at the end of my presentation. I have covered exactly the 25 minutes. Pranjal, I think we have now 5 minutes left for questions, if there are some already coming in.
All right, thanks, Alex. Very interesting presentation. Some interesting reference designs and product comparisons there. Looks like your presentation was absolutely perfect, because I don't see any questions coming in. Nevertheless, if you have any questions, you can always post them at go.chemet.com/did-contact. So because we don't have any more sessions coming in, then we would have to say that this would be the end of this session. Thank you for attending this presentation of Design It Day. Please be sure to check out our other great presentations today. Have a nice day and rest of the event. And thank you again, Alex.
Thank you, Pranjal.